We've done a lot of deep dives into some pretty wild corners of space, but I think today's topic might take the cake for sheer mystery.
Oh, I like where this is going. What have
No?
you got for us?
Yep, well, it all starts with something you might remember. Oumuamua, that interstellar visitor that, basically crashed our solar system party back in 2017.
Oh yeah, Oumuamua, the one that had everybody scratching their heads about whether it was an asteroid or a comet.
Exactly. At first, everyone was pretty sure it was just another asteroid, just a hunk of rock cruising through space.
Right.
But then things got a little weird. Oumuamua started acting up, exhibiting some very, very peculiar behavior that was, it was almost like a comet, but without the classic comet tail.
So like a comet in disguise.
Exactly. And that's what brings us to today's deep dive, dark comets.
Dark comets, huh? Those cosmic masqueraders blending in with the asteroids but secretly harboring a cometary heart.
I like that, a cometary heart. And what's even more mind-blowing is that scientists have recently discovered a whole bunch more of these dark comets, like doubling the number we knew about.
Wow, hiding in plain sight all this time. So what's the deal with these dark comets? What makes them so different from your average garden variety asteroid?
Yeah, they both just look like tiny points of light against the vast cosmic backdrop, right?
You're absolutely right. To the untrained eye, or even a seasoned astronomer peering through a telescope, they might seem indistinguishable at first, but the key to unlocking their secret identity lies in their movement.
Their movement. Okay, I'm intrigued. Tell me more.
Well, imagine a tiny asteroid just minding its own business, cruising through space, and then suddenly it gets nudged off course by an invisible force.
An invisible force. Sounds spooky.
It's not ghosts, I promise. That force is actually coming from the outgassing of volatile materials, things like water ice, carbon dioxide, or methane trapped beneath the surface.
Outgassing. So is that like what happens with regular comets?
It is. The iconic comet tail is created when sunlight heats up those volatiles, and they essentially erupt from the comet's surface, creating that spectacular trail of gas and dust.
Right. The comet's signature move. But you're saying these dark comets, they do the same thing, just without the flashy visuals.
Precisely. With dark comets, this outgassing process is much more subtle, so they don't produce a visible tail. It's like they're whispering their cometary secrets instead of, shouting them from the rooftops.
So it's more of a stealthy comet situation. But if they're so good at hiding, how did we even figure out they existed in the first place?
Well, it's a bit of a detective story. It all started back in 2003 with an object rather uncreatively named 2003 RM. At first, astronomers just thought it was your typical run-of-the-mill near-Earth asteroid. But then they started noticing something a little off about its trajectory. Its path was being slightly altered in a way that just screamed cometary activity, even though, there was no visible tail to back it up.
So 2003 RM was like the original dark comet trailblazer. But it took Oumuamua, with its similar disappearing act, to really solidify the concept right.
You got it. Oumuamua's strange acceleration, despite the lack of any visible tail, mirrored what was observed with 2003 RM. It was like Oumuamua came along and said, hey, remember that weird thing you saw back in 2003? Yeah, that wasn't a fluke. That was a dark comet.
And now we've got not one, but two distinct families of these cosmic enigmas. What's the scoop on these different groups?
Okay, so picture the solar system as a giant, racetrack, if you will. The outer dark comets, as you might have guessed, are found in the outer lanes, way out beyond Jupiter. Their orbits are, highly elliptical, meaning they're stretched out, almost like a rubber band being pulled around the sun. They also tend to be on the larger side, resembling the Jupiter family comets. The inner dark comets, on the other hand, stick to the inner lanes closer to the sun. Their orbits are neat and tidy, almost perfectly circular, and they're generally smaller in stature.
Okay, so two different groups of dark comets, each with its own orbital style, I guess you could say. But where did they come from? What's their origin story?
Well, that's the million-dollar question that has astronomers scratching their heads and piecing together the cosmic puzzle. There's a fascinating theory that these dark comets might be fragments of larger bodies from the main asteroid belt, that region between Mars and Jupiter.
Right, the asteroid belt always bustling with activity.
Exactly. So imagine a cosmic billiards game with asteroids constantly colliding and breaking apart, sending fragments scattering in all directions. Some of those fragments might have gotten flung outward, becoming the outer dark comets we see today. Others might have stayed closer to home, forming the inner dark comet population.
Wow, a cosmic demolition derby, creating these hidden cometary treasures. But here's a thought. We often talk about regular comets as potential delivery systems for the building blocks of life, bringing water and organic molecules to early Earth.
Yeah.
Could these dark comets also have played a role in that story?
It's a question that has scientists incredibly excited. I mean, think about it. These dark comets have been cruising around the solar system for billions of years, potentially carrying those vital ingredients for life, like water ice, carbon dioxide, and even more complex organic molecules.
It's amazing to think that these unassuming objects, these masters of disguise, could hold the key to understanding the very origins of life on our planet, and maybe even elsewhere in the universe.
Exactly. It really underscores the vastness of the universe and how much there still is to discover.
Well, there you have it, folks, another cosmic mystery for you to ponder. Who knows what secrets these dark comets might reveal in the years to come?
Well, that's science for you. Always more questions than answers, but the journey of discovery is half the fun.
Couldn't have said it better myself. Thanks for joining me on this deep dive into the world of dark comets.
The pleasure was all mine. Until next time.
And to all of you listening out there, don't forget to subscribe for more deep dives into the mysteries of space and science. And who knows, maybe one of you will be the one to unlock the secrets of the dark comets.
Keep looking up.
And keep those questions coming. Until next time.